When an expression inside parentheses is raised to a power, the inside expression is the base. So here we have this quantity inside the parenthesis raised to the power of 2. We'll treat the 3x as the base. So the result in factor notation is 3x times 3x. If we simplify this, we have multiplication, which we can use the commutative property to put our like terms together, and simplifying further, 3 times 3, common base, we have 3 to the power of 2 times x to the power of 2, since we have the common base of x multiplied by itself 2 times as well. Simplifying that, 3 squared, we could have put 9 times x squared for our simplified answer. In this value here, only the x is raised to the second power. Notice the difference. It was the expression within the parenthesis that was raised to the power. Here there is no parenthesis, and so in expanded notation, this would be 3 times x to the power 2, which expands to x times x. When we have a product raised to a power, like we did in this first example, for any numbers a and b and any whole number n, if we have a product raised to a power, each one of those factors of that product are raised to that power. Using the product raised to a power rule to simplify these next examples, we will take each of the factors, which there's 2 factors being raised to the second power, which will lead us 3 to the power of 2 times y to the power of 2. Simplifying, because of the fact we have an integer rather small raised to the second power, 3 to the power of 2 is 3 times 3 or 9. Our simplified equivalent value is 9y to the second power. In this next example, we have 2 factors here. We have -2 and a to the third that are being raised to the second power. Applying the product raised to a power, we'll take our first factor, -2, raise it to the second power, and our second factor, which is a term in exponential form, but it's raised to the second power. Simplifying this further, -2 squared means -2 times -2. A negative times a negative is positive, and 2 times 2 is 4. And raising this product to a power results in having a power raised to a power. Using that power rule, we will multiply those exponents, resulting in a to the 6th power, because 3 times 2 is 6. So an equivalent value to this original expression is for a to the 6th power. Taking a look at this next expression and considering order of operations, we have a product raised to a power times a product. The exponent will take the priority following the order of operations. And in this case, we have an application of a product raised to a power. Each of these factors, which there's 2 factors in here, will be raised to the 3rd power. So we have 5, or x to the 5th power, raised to the 3rd power. The second factor, which is y, is raised to the 3rd power, and then it's being multiplied by the quantity x to the 2nd, y to the 3rd. When we have a exponent raised to a power raised to a power, the power rule says we can simplify by multiplying the exponents together. 5 times 3 is 15. We have our y to the third, and it's being multiplied by a product as well, so we can eliminate the parentheses. And further, using commutative properties, simplify this. By rearranging our all multiplication operation and putting like terms together, we can see we have common bases multiplied together, and now using the product rule, when you have common bases multiplied together, add the exponents. 15 plus 2 is 17. Common base of y, add the exponents because those bases are multiplied, results in a 3 plus 3 or 6 for our final simplification of this expression.